All right, so let's take a look at rational exponents. And that means that the exponents are fractions. So when we have a number being raised to a power that is a fraction, what can happen there is that numerator is the exponent and the denominator becomes the root. Okay, so if we have b to the p over q, then that q becomes the root and the p is the exponent. So it can be written in these two ways. So let's take a look at example number 1 and use some numbers here. So if we have 81 to the power of 3 over 2, we make that 2 a root. So you can write that 2 there. If you don't write it, it's assumed to be a 2 anyway. And then the 81 goes inside. And then the 81 goes inside, and the 3 becomes the exponent. Okay? So what's the square root of 81? 9. And then 9 to the third gives us 729. And that's all you do. Now let's take a look at example 2. Remember that our root is the denominator. So we have a cube root of 8 to the power of -5. Okay? Whenever there's a negative there, always make that the exponent because it's a lot easier to deal with. All right, so the cube root of 8 is 2 to the -5. Remember that a negative exponent means it comes down, it becomes a fraction. And then, so it's 1 over 2 to the 5th, and then 2 to the 5th is 32. And then that is your answer. Now let's take a look at example 3. Now we have a decimal as our exponent. So let's make it a little bit easier and change it to a fraction. I know usually you don't think fractions are going to be easier than decimals, but in this case it is. So that's going to become 9 to the 3/2, because remember, 1.5 as a decimal, written as an improper fraction, is 3 over 2. All right, so remember the 2 becomes the root, and the 3 becomes the exponent. So what's the square root of 9? 3. And 3 cubed is 27. Now let's take a look at number 4. Gets a little more complicated here, but as long as we take it step by step, you'll be fine. All right, so first let's change this into an exponent. Okay, so let's not deal with that -3/4 just yet, and we'll work the inside first. So we have 1 over, and that becomes 81 to the 1/3, because what's the exponent inside the parentheses there? The exponent is a 1, and that root is a 3, so 1 over 3. So that's 81 to the 1/3. Keep in mind that it's on the bottom of the fraction. All right, so we still need to do something with that 81 to the 1/3 because it's in the denominator. So let's leave the parentheses alone for now. And how do we bring this up to the top? We make the exponent negative. So we have 81 to the -1/3. Now remember your laws of exponents. When you have something to a power raised to another power, you multiply those exponents. So we have 81, and then when we multiply these, the 3's are going to cancel and the negatives are going to cancel, so you're left with 1 over 4, which is the same thing as saying the 4th root of 81. And the 4th root of 81 is 3. So let's take a look at example number 5. We've got square root of 1/3 and the cube root of 9. So let's get rid of the radicals because they're not even the same root and change them into rational exponents. So that way we can work with them. All right, so we have square root of 1 over 3. And so we can make that 1 over the square root of 3. And so that's going to become 1 over 3 to the 1/2, because remember, the root becomes the denominator for the exponent, and then there's no exponent there, so it's just a 1. So it becomes 1/2. And then to move it up to the top, that becomes a negative 1/2, okay, to get rid of the fraction there. And then the the cube root of 9 is going to become 9 to the 1/3. Again, the root becomes the denominator for the exponent, and the exponent is the numerator. All right, and then they were being multiplied together, so we have, we're going to multiply these two together, but can you multiply them when the bases aren't the same? No, we can't. So let's change the 9 so that it has a base of 3. So this is going to become 3 squared to the 1/3. Okay, 9 becomes 3 squared, still to the 1/3. And then what do we do with those exponents? We multiply them. So we have 3 to the 2/3. Now we have the same base, so we can go ahead and multiply. So we have the 3 to the negative 1/2 times 3 to the 2/3. Now how do we multiply two bases, two of the same bases with different exponents? What do we do with those exponents? We add them. So it's going to be 3 to the negative 1/2 plus 2/3, and that's going to give us 1/6. And then you can rewrite that as the 6th root of 3 if you wish. Either one of these is an acceptable answer. So I'll circle both of them. Now let's take a look at example 6. Write the cube root of 9 times the square root of 3 in exponential form and in simplest radical form. All right, so first let's change these radicals into rational exponents. So we have 9 to the 1/3 times 3 to the 1/2. Well, we don't have the same basis here, so let's get the same basis. So that 9 becomes a 3 squared. Remember that it's still to the power of 1/3 times 3 to the 1/2. And then we just multiply those two exponents here to get 2/3 times 3 to the 1/2. And then what do we do with the exponents? We add them. So it becomes 3 to the 7/6. All right, so we have 3 to the 7/6. So we can rewrite that as 3 to the 6/6 times 3 to the 1/6, because if you add those, well, that gives you 7/6. And then what happens here with 6/6? It's just 1, so you have a 3, and then you have a 6th root of 3. Another way of looking at that is what's 7 minus 6? You have 1. So you can pull 1 out. I'm sorry, not 7 minus 6. What's 7 divided by 6? It's 1 whole with 1 left over. So here's your whole, and there's your 1 left over inside that radical. Now let's take a look at example 7. All right, we want to solve this equation. So the first thing we're going to do, remember your order of operations, we're going to do the inverse order of operations. So the first thing we want to do is get rid of any addition or subtraction. We don't have any. So now we're going to look at multiplication and division. Well, we have that 6 there, so we're going to divide both sides by 6. So we have x to the 2/3 equals 9. Now we need to get rid of the exponents. So you could multiply, or I'm sorry, not multiply, but raise both sides to the power of 3/2. Because what that's going to do for your x is that's going to get rid of that exponent, and it's just going to be an exponent of 1. So x equals 9 to the 3/2. Well, now you can rewrite that in radical form. So that's going to equal the square root of 9 to the 3rd. Now, if you want to write that 2 in, you can. What's the square root of 9? 3. To the 3rd is 27. So x equals 27. Now let's take a look at example 8. All right, again, we have an equation, so we want to use our inverse operations, addition and subtraction. Do we have any here? Yes, we have a 3, so let's add that 3 over to the other side. All right, now at this point, we don't have any more addition or subtraction except for inside the parentheses, but that's your first step for order of operations, so when we're using inverse, it's the last. Okay, so we don't have any multiplication or division here, but we do have an exponent, so let's get rid of the exponent. So let's raise both sides to the power of 5/2. That will turn this exponent into a 1, because the 5's cancel and the 2's cancel, so you get a 1. And then it raises the 4 to the power of 5/2. So now we have t minus 4 equals the square root of 4 to the 5th power. So t minus 4 equals 2 to the 5th. So t minus 4 equals 32. So t equals 36. And that's your answer.